Good morning students. Thank you very much students for clicking on my video. I am your Nagini ma'am, chemistry mentor. In today's section I am going to discuss about the types of overlapping students. This is the topic from chemical bonding lesson 11th class first PUC. Clear? So in this section I am going to discuss about the types of overlapping students. Types of overlappings. So after this topic students, you will get the clear idea on this topic students. You can easily answer which type of overlapping is taking place in the given molecule. You can easily answer such type of questions students. Okay Namma. So first types of overlappings. Types of overlapping. Now see students. So in types of overlapping students, there are different types: SS overlapping, SP overlapping, PP overlapping. Yes, there are three different types of overlappings are there, correct? So first one is SS overlapping. SS overlapping, SS overlapping, SP overlapping. Okay. Next one, PP overlapping. PP overlapping. So like this different types of overlappings are there: SS overlapping, SP overlapping, PP overlapping students. Here SS overlapping and SP overlapping students, because of these two overlaps, sigma bond is formed. Which bond is formed students? Sigma bond is formed. Okay, sigma bond. And here in PP overlapping students, there are two different types of overlappings are there. One is axial overlapping, another one is lateral overlapping. Clear? So one is axial overlapping, another one is lateral overlapping. Clear? Lateral overlapping. There are two different types of overlappings. Okay, one is axial overlapping, second one is lateral overlapping. Now due to the axial overlapping students, PP axial overlapping, which type of bond is formed? Sigma bond is formed. Okay, sigma bond is formed. Now because of lateral overlapping, pi bond is formed. Correct? Pi bond is formed. Understood, Amma? Pi bond is formed. So, first of all, what is sigma bond? What is pi bond? A chemical bond. So, here a covalent bond is classified into two different types, students. Classified into two types. Covalent bond. What are the two types? Sigma bond and pi bond. Are you clear? Depending on the type of overlapping. Based on the types of overlapping students. Based on the types of overlapping. Here covalent bond is classified into two different types. Nana. Okay. Based on the type of overlapping. Okay. Covalent bond is classified into two types. Okay, so what are the two types? One is sigma bond students, another one is pi bond. Okay, what is sigma bond students? How sigma bond is formed? First I will discuss the sigma bond definition, pi bond definition. Later we will discuss SS overlapping, SP overlapping, okay, PP overlapping. Because here sigma bond is formed, here SS overlapping, SP overlapping, sigma bond is formed. In PP overlapping, because of lateral overlapping, pi bond is formed. Because of axial overlapping, sigma bond is formed. Clear? So what is sigma bond? What is pi bond? We have to discuss. What is the sigma bond students? A covalent bond formed by the end-to-end overlapping of half-filled atomic orbitals of two atoms along the internuclear axis. Okay, na? What is sigma bond students? How it is formed? Sigma bond, it is formed by the end-to-end overlapping. Okay, end-to-end overlapping. End-to-end overlapping of half-filled orbitals of two atoms. Okay, now overlapping of half-filled orbitals of two atoms. Okay, now two atoms along the internuclear axis. Students, along the internuclear axis. Internuclear axis. So how sigma bond is formed? End-to-end overlapping of half-filled orbitals of the two atoms along the internuclear axis. Pi bond, how it is formed, students? Pi bond is formed by the sidewise overlapping half-filled orbitals of two atoms perpendicular to the internuclear axis. Okay, now perpendicular to the internuclear axis. What is the definition, students? Pi bond, it is obtained by the sidewise overlapping. Sidewise overlapping. Clear? It is obtained by the sidewise overlapping of half-filled orbitals of two atoms. Half-filled orbitals of two atoms. Okay, two atoms perpendicular to the internuclear axis. Perpendicular to the internuclear axis. Clear this one? Perpendicular to the internuclear axis. This is the pi bond. Understanding? So end to end overlapping. End to end overlapping is nothing but like this. Okay, end to this this atomic orbital, this atomic orbital, end to end. This is the end to end overlapping. One coming to the pi bond, students. What is pi bond? Sidewise overlapping means like this. Okay now, so sidewise overlapping, these sides undergoes overlapping, students. Okay now, with orbitals now I am going to discuss. End to end means like this. Okay, so that's why it is a strong bond. To break this bond, more energy is required. Are you understanding? To break the sigma bond, more energy is required because sigma bond is a strong bond because of greater extent of overlapping. But pi bond is a weak bond because sidewise overlapping, we can easily break this bond. Are you understanding? We can easily break this bond. Understood, Narma? Now, we will discuss the SS overlapping. Just one sentence. A sigma bond. What is sigma bond here? It is a strong bond. It is a strong bond. Why it is strong bond, students? Because of greater extent of overlapping. Greater extent of overlapping. Understood, Amma? Greater extent of overlapping. It is a strong bond. Pi bond is a weak bond, students. Why it is a weak bond? It is a weak bond because of smaller extent of overlapping. Okay, now one first type SS overlapping I am going to discuss. SS overlapping, first one. SS overlapping, first type, students. SS overlapping. SS overlapping. Now coming to the SS overlapping, students. SS overlapping. What is happening, Nana? SS overlapping. SS overlapping. What is SS overlapping? In SS overlapping, students, half-filled s orbital of one atom overlaps with the half-filled s orbital of another atom along the internuclear axis. That is called SS overlapping, students. Okay, now what is SS overlapping, students? In this case, now see, students, SS overlapping. What is SS overlapping, students? Half-filled s orbital of one atom overlap with the half-filled s orbital of another atom along the internuclear axis, students. Understanding? So that is SS overlapping. Here, what is the definition, students? SS overlapping. Half-filled s orbital of one atom. Half-filled s orbital of one atom overlaps with the half-filled s orbital of another atom. Clear? Half-filled s orbital of another atom along the internuclear axis. Along the internuclear axis. Now see, students, here what is the definition? SS overlapping. Half-filled s orbital of one atom overlaps with the half-filled s orbital of another atom, students. For example, here I am taking H2 molecule. Example, H2 I am taking. Hydrogen atomic number is 1, electronic configuration 1s1. In 1s subshell only one electron is present. Okay, now here two hydrogen atoms are there. Take one more hydrogen and 1s1. Here also in 1s one electron is present. Understood, Amma? One electron is present. So here this half-filled s orbital of hydrogen atom overlaps with the half-filled s orbital of another atom. Half-filled s orbital of hydrogen atom, another hydrogen atom along the internuclear axis. We know that s orbital shape is spherical shape, correct? S orbital shape is which one, Nana? Spherical shape. Its shape is spherical. S orbital. Okay, now see students, s orbital shape is spherical. So that's why I am taking here spherical shape s orbital. This is the nucleus. This is the s orbital of hydrogen atom, and this is the s orbital of another hydrogen atom, half filled s orbital of another hydrogen atom, students. So this is the spherical shape. Here nucleus. Okay, this is the internuclear axis, students. This is the internuclear axis. Now see here, I am taking the electron here. One hydrogen atom electron. Here this is another hydrogen atom electron. This electrons how I am taking, see here. This is the first hydrogen atom. This is the second hydrogen atom, students. Okay, second hydrogen atom. Here how many electrons there? Half filled. One electron is present. So that electron I am taking as clockwise, and this electron I am taking as anti-clockwise direction, because both are different atoms, students. Okay, now two hydrogen atoms, one hydrogen atom electron like this, another hydrogen atom you have to take anti-clockwise direction. Now these two orbitals overlaps with the undergoes overlapping, students. Undergoes overlapping. What is produces, Rana? Undergoes overlapping produces sigma bond. That means this orbital end undergoes end to end overlapping, this one. So this is the sigma bond, students. This is which type of sigma bond? This is which orbital? S orbital. This is also S orbital. So that's why here sigma SS type of overlapping is taking place. Are you clear? Sigma, which type of bond? This is SS. Are you understanding? This is S orbital. This is also S orbital. So here SS overlapping is taking place. So this is the nucleus. This atom nucleus is this one. This is the internuclear axis, students. This is the internuclear axis. So here what you have to say? SS overlapping. Here this is which molecule? H2 molecule. H2 molecule. Clear? Which type of bond is formed? Sigma bond. Okay, now these two electrons right here. These two electrons like this I am taking. Okay, now. So here sigma bond is formed. Understanding, students? So that means here in between the two hydrogen atoms, which bond is formed? Single bond is formed. H single bond H. Clear this one? So here bond indicates two electrons, Nana. Bond indicates two electrons. So this is the SS overlapping. Understanding? So here hydrogen atom S orbital half filled and another hydrogen atom half filled S orbital, both are undergoing overlapping, produces sigma bond, end to end overlapping. So that's why half filled s orbital of one atom overlaps with the half filled s orbital of another atom along the internuclear axis. This is the internuclear axis. This is the nucleus. This is the nucleus. Internuclear axis. Okay. Now I am going to discuss the sp overlapping. Sp overlapping. Now tell me, students, sp overlapping. So because of SS overlapping, sigma bond is formed. Because of sp overlapping also, sigma bond only formed. What is the definition, students? Half filled s orbital of one atom overlaps with the half filled p orbital of another atom along the internuclear axis. Correct? So what is the definition? Half filled s orbital. This is s orbital. This is p orbital. So s orbital, p orbital undergoing overlapping. So half filled s orbital of one atom overlaps with the half filled p orbital of another atom. Clear? P orbital of another atom along the internuclear axis. Along the internuclear axis. Clear this one. So half-filled s orbital of one atom and overlaps with the half-filled p orbital of another atom along the internuclear axis. Which bond is formed, students? Sigma bond is formed. Take here one example, Nana. sp overlapping. Example, students. HCl molecule I am taking. Here hydrogen chloride. Hydrogen atom is having one electron, atomic number 1, electronic configuration 1s1. So this is the 1s1, and chlorine atomic number is 17, 1s2, 2s2, 1s2, 2s2, 2p6, 3s2, 3p5. Correct? 3s2, 3p5. Now coming to the 3s2, students, 3s2 electrons in 3p, 5 electrons are there. 1, 2, 3, 4, 4, 5. That means only one unpaired electron is present. One half-filled orbital is there. This is px, py, pz. So this is the pz orbital. This is the pz. 3pz is having the half-filled orbital. Half-filled. So that's why here this is half-filled s orbital of hydrogen undergoes overlapping with the half-filled p orbital of half-filled pz orbital of chlorine atom. Clear? Along the internuclear axis. What is the pz orbital shape, students? What is the pz orbital? Dumbbell shape. Okay, dumbbell shape means like this. Clear this one. Now see, students, HCl, hydrogen atom s orbital, chlorine atom pz orbital undergoes overlapping. Clear? So that's why here hydrogen atom, which orbital, students? S orbital. Hydrogen atom s orbital. This is hydrogen atom s orbital, students, undergoes overlapping with the chlorine atom pz orbital. So this is the pz orbital of chlorine atom, 3pz orbital. Okay, here how many? This is the internuclear axis, students. Now here how many electrons there? One electron. Here also one electron. Another atom, you have to take the anti-clockwise direction. Now see here, these two orbitals undergoes overlapping, produces sp overlapping, students. Sp overlapping means like this. This is s orbital, this is p orbital, students. Okay, this is here electron and this electron here will come, forms the sigma bond. Which type of sigma? This is s orbital. This is which orbital? P orbital, spz. Clear this one. So s orbital, pz orbital undergoes overlapping, produces sigma bond, students. Are you clear? So this is s orbital, this is pz orbital. This is which molecule? This is hydrogen atom s orbital. This is the chlorine atom 3pz orbital undergoes overlapping, produces hydrogen chloride. Okay, now hydrogen chloride molecule is formed. This is the sp overlapping. Are you clear? Now I am going to discuss pp overlapping. PP overlapping. In PP overlapping, students, already I told you there are two types are there. First one is axial overlapping. Okay, now axial overlapping. So here already I told you, students, axial overlapping, correct? And next one, lateral overlapping. First I will discuss the axial overlapping. Because of axial overlapping also, which bond is formed? Sigma bond only formed. Sigma bond is formed. Here I am taking the example, students, PP overlapping. Example, fluorine. Example, fluorine I am taking. F2 molecule. Now fluorine atomic number is 9. 1s2, 2s2, 2p5. That means in 2s2, 2p5, 2s2, 2 electrons. In 2p, 5 electrons are there. 1, 2, 3, 4, 5. One half filled. Are you clear? Px, Py, Pz. This is the Pz orbital half filled. And one more fluorine, because here two fluorine atoms are present in the F2 molecule. So one more fluorine also I am taking. Fluorine 9. Electronic configuration is 1s2, 2s2, 2p5. 2s2, 2p5, 2 electrons. In 2p, how many electrons there? 1, 2, 3, 4, 5. That means here pz orbital is half filled. So both are having the same electronic configuration. One fluorine atom pz half filled orbital and another fluorine atom half filled pz orbital undergoes overlapping, students. What is the definition PP overlapping? What is the definition? Half filled p orbital of one atom This is the half filled p orbital of fluorine atom overlaps with the half filled p orbital of another fluorine atom along the internuclear axis. Are you clear? So that is nothing but pp overlapping, students. What is the definition pp overlapping? What is the definition, students? Half filled p orbital, half filled p orbital of an atom overlaps with the half filled p orbital of another atom. Are you clear? Another atom along the internuclear axis. Understood, Amma? So that is called pp overlapping. Okay, now half filled p orbital. This is half filled p orbital of fluorine atom overlaps with the half filled p orbital of another fluorine atom. Clear? Along the internuclear axis. Understanding? Overlaps with the half filled p orbital of another atom along the internuclear axis. Now see, students, this pz orbital. Pz orbital shape is which one? Pz orbital shape is which one, students? Dumbbell shape. Okay, now so first fluorine atom I am taking. Its shape is dumbbell shape. This is the pz orbital, dumbbell shape. This is the internuclear axis. Okay, internuclear axis. And one more pz. This is one more pz orbital of fluorine atom. This is the dumbbell shape pz orbital. Okay, this is 2pz, this is 2pz. Okay, now here how many electrons are there, students? One electron is there. That electron I am taking here. One electron is clockwise, another electron I am taking as opposite spin. Then both are undergoing overlapping, students. Then produces which one, students? Sigma bond is formed. Okay, na? So these two atomic orbitals are undergoing overlapping, produces which type of bond? Sigma bond. This is sigma bond, students. Here two electrons. This electron will come to here. Sigma bond is formed. This is which type of sigma bond? PZ. That's why sigma PP type of overlapping sigma bond is formed. This is hydrogen. This is which one? Fluorine atom. This is the fluorine atom. This is another fluorine atom. This is about F2 molecule. Are you clear? So F2 is formed. So here how many sigma bonds are present in between the two fluorine atoms, students? Two fluorines, one sigma bond. Are you clear? Here this is a sigma bond, indicates two electrons, single bond, covalent bond. F single bond, F2 molecule. This is the axial overlapping. This overlapping is taking place along the internuclear axis. That's why we'll call it as sigma bond. Along the internuclear axis, sigma bond is formed. Then we'll call it as which bond, students? Sigma bond. Clear? This is PP type of overlapping, students. This is axial overlapping. Now I am going to discuss about the lateral overlapping, PP overlapping. Okay, now see, students, PP overlapping. PP overlapping. This is which type of overlapping, students? Lateral overlapping. We know that lateral overlapping, because of lateral overlapping or sidewise overlapping, pi bond is formed. Correct? This is the lateral overlapping. So which bond is formed? Pi bond is formed. Clear this one? Pi bond is formed. Okay. Now PP type of overlapping. Here I am taking example, students. Example, nitrogen taking N2. Nitrogen. What is the definition? PP overlapping, students. What is the definition? Half filled p orbital of one atom overlaps with the half filled p orbital of another atom. Okay, now perpendicular to the internuclear axis. Are you understanding? Okay, now so it is perpendicular to the internuclear axis. The two atomic orbitals are undergoing overlapping. Clear this one? So what is the definition, students? What is the definition? PP overlapping? Half filled p orbital of one atom overlaps with the half filled p orbital of another atom. Okay, another atom perpendicular to the internuclear axis. Perpendicular to the internuclear axis. Understanding, students? Along the internuclear axis, sigma bond is formed. Perpendicular to the internuclear axis, which bond is formed? Internuclear axis, pi bond is formed. Clear this one? Pi bond is formed. Okay. Now see, students, nitrogen atom. What is electronic config? Atomic number 7. Electronic configuration 1s2, 2s2, 2p3. 2s to 2p3. That means in 2p3, how many half filled orbitals are there? 1, 2, 3. Correct? That means px, py, pz. Here 3 orbitals are involving in the overlapping, students. This one more nitrogen atom. What is one more nitrogen atom? Atomic number 7. 1s2, 2s2, 2p3. Here also same thing. 2p3. 1, 2, 3. This is px, py, pz. Correct? Px, py, pz. Now these 3 orbitals half filled undergoing overlapping with the these 3 orbitals of another nitrogen atom produces sigma and pi bonds, students. See here, I am going to draw the structures. Px, py, pz. Suppose this is the px orbital, this is the py orbital. Clear this one? Py orbital, and pz orbital is this one. Clear? pz orbital. 3 orbitals are there. Okay, this is the internuclear axis. Just here in px, how many electrons? 1 electron. Here in py, 1 electron. In pz also 1 electron. So this is first nitrogen atom completed. Are you clear? So this is the px, this is the py, this is the pz orbital. Dumbbell shape. Are you clear, students? It is undergoing overlapping with the, it is combined with another nitrogen atom, p orbitals. So what are the p orbitals, students? Again px, this is py, this is pz. Clear, students? This is px, py, pz. Here what are the electrons are there? In px anti-clockwise direction, px 1 electron, py 1 electron, pz 1 electron undergoes overlapping, produces, students, see here, sigma pi bonds. Triple bond is formed here. Now see, students, this px undergoing overlapping, end to end overlapping, like this, end to end overlapping. Next, this is the py, this is the py orbital. Okay, and this is the pz, this is the pz orbital. Okay, pz orbital. Here 2 electrons will come, here 1 electron, here 1 electron, and this is the pz electron, this is the pz electron. Now these 2 electrons are undergoing overlapping. This is the nitrogen atom, this is also another nitrogen atom, students. This is N2 molecule. N2 molecule. This is which type of bond? Sigma px, correct? Sigma px, and this y orbital, students, undergo sidewise overlapping like this. Okay, now sidewise overlapping, and this pz orbital are undergoing sidewise overlapping, students. Are you clear? Sidewise overlapping. So this is the pz orbital, students. Clear this one? So here these 2 orbitals px undergoing overlapping along the internuclear axis. This is the internuclear axis, students. Along the internuclear axis, sigma bond is formed. This is sigma p2p, pp orbitals are undergoing overlapping, sigma bond is formed. And here this is py orbitals are undergoing sidewise overlapping. Sidewise overlapping means like this. End to end means like this. Are you clear? So here 1 sigma, 2 pi bonds are formed. Are you clear? So here N2 molecule, here 1 sigma, this is pi bond, this is pi bond, and here also this is pi bond. Total in between the nitrogen atoms, triple bond is formed. Triple bond is nothing but 1 bond is sigma, remaining 2 pi bonds. So what bonds, students? Pi bonds. Are you clear? Sigma bond, pi bond, pi bond. Because we know that sigma bond has independent existence, students. So that means it can form, it can form alone or along with pi bond. Okay, now, but here pi bond has no independent existence, students. It has no independent existence. So that's why pi bond is always formed along with the sigma bond. So that's why after the formation of sigma bond only, pi bond formation takes place. Are you clear? Understanding? So here this is sigma, these two are pi bonds, Nana. Okay, so that means in between the two nitrogen atoms, Nana, triple bond is existing. One sigma, two pi bonds will be there. This is the N2 molecule. Clear this one? Now one more example, students. PP overlapping, lateral overlapping. One more example, oxygen I am going to discuss. Now see, students, oxygen molecule. Second example, here I am taking. See here. Second example, lateral overlapping only. I am taking the different example, lateral overlapping. Okay, lateral overlapping, Nana. Which example? O2 I am taking, O2 molecule. So here oxygen atom atomic number 8, 1s2, 2s2, 2p4 electronic configuration. In 2p, 1, 2, 3, 4 electrons are there. That means py, pz are having the half filled, py, pz are half filled orbitals. So this is one oxygen atom. Another oxygen atom atomic number is 8, 1s2, 2s2, 2p4. Here also in 2p, here 1, 2, 3, 4. It is also having the two p's, py, pz orbitals are half filled. This is px, this is px. Now these two orbitals of py, pz orbital of one oxygen atom undergoes overlapping with the py, pz half filled orbitals of oxygen atom, students. Now this oxygen atom, what is the py orbital? This is the py orbital, this is the pz orbital of one oxygen atom. This is pz. Okay, now here one electron here in the pz, and py also is having one electron. I am taking as a clockwise direction. This is the internuclear axis. It is combined. This is one oxygen atom, students. One more oxygen atom is this one. This is py and this is pz orbital. This is internuclear axis. Here electrons, how many are there? In another oxygen atom, py, pz, two electrons. In py, one electron is there. This is py, this is pz. In py, one electron. In pz, another pz also one electron is there. Both are undergoing overlapping, students. py, py undergoing axial overlapping, and pz, pz orbitals are undergoing sidewise overlapping, lateral overlapping, students. Now see here. This is py, py undergoing overlapping. It is end to end overlapping, students, along the internuclear axis. This is the pz, pz orbitals are undergoing, students, here. Sidewise overlapping. This is pi bond is formed. This is sigma bond. Which type of bond? This is py, this is py, this is pz, this is pz. py, orbitals are undergoing end to end overlapping. Sigma bond is formed. These are sidewise overlapping. So which type of bond? Pi bond is formed. So that means here how many bonds are formed between the two oxygen atoms, students? This is also oxygen atom. This is O2 molecule. So in between the oxygen and oxygen, here two bonds are there. One sigma, one pi bond. Because only two orbitals are there, double bond. That means here one sigma, one pi bond is present. Clear this one? One sigma and one pi bond is present, students. Are you clear? So you remember, students, single bond indicates sigma bond. Okay, double bond indicates, here double bond is formed, one sigma, one pi. Okay, so double bond is formed. Double bond means one sigma, one pi bond. Triple bond, in triple bond, Nana, in triple bond, students, in triple bond. Okay, so in triple bond, one sigma, two pi bonds will be there. Are you clear? One sigma, one pi bond. Understanding, students? And here one sigma, two pi bonds. Clear? One sigma, two pi bonds, students. Triple bond means one sigma, two pi bonds. Clear this one? So this is the types of overlapping, students. Okay, I hope you like this video, students. If you like this video, please like, share, comment and subscribe my channel, students. Okay, thank you very much, Nana.